Welcome to Database Information Retrieval Systems Assessment 4.2. Today I will be discussing different aspects of client-server systems including security, single point of failure, backup systems, scalability, front and back-end processors, client and server-side code, and internet file sharing. One of the beneficial features of a client-server system is improved security. Improved security is achieved through a managed infrastructure, but there are some disadvantages. A managed infrastructure requires skilled IT support engineers to implement and maintain. Employing IT support engineers as well as designing and building an infrastructure can be expensive, as specialized hardware and complex configurations may be required. For an ongoing basis, system updates must be scheduled. Failure to update a system can expose the system to security vulnerabilities. A compromised system could cost a company lost revenue or productivity. One example of this is with a web-based access control door lock system. In this type of system, user accounts and magnetic badges must be assigned and maintained by an administrator. Failure to do so could result in unauthorized access. Client-server systems by design have a single point of failure. When servers fail, it can stop business activity and impact end-user experience. For instance, when a web server fails, users are presented with websites that partially function or don't function at all. Creating server redundancies can help to reduce the risk of failure. High availability systems help to prevent server downtime, but are expensive to implement and require special configuration. One example of a high availability system is a pair of identical enterprise firewalls running in sync. If the primary firewall of the pair goes offline, the secondary firewall immediately takes over and becomes the primary. In a system like this, end users are unable to notice the disruption. In some cases, backup systems are necessary to help mitigate the risk of server failures. Servers that contain critical data are likely to have a backup system in place include database servers, web servers, application servers, file servers, and network appliances. To keep this critical data safe and secure, dedicated backup systems are capable of performing backups very frequently. Some are capable of storing archive data for long periods of time and can take snapshots of data that can be restored from different points in time. Locally hosted backup servers can be configured to synchronize data to cloud servers for additional redundancy for physical disaster scenarios. A network backup appliance is a great example of a server that backs up data on a local network, but also syncs the data to cloud backup servers. A client-server system is considered to be scalable by its ability to expand as processes change, new functionality is needed, hardware becomes limited, and as connectivity demands increase. Special planning and design are needed for a client-server system architecture to prepare for future growth. A great example of this is a fiber internet connection. While a fiber interface may be set to 1 gigabits per second, the actual throughput may be different set by an ISP based on the actual customer bandwidth needs. As customer demands for throughput increase, an ISP can adjust the bandwidth as needed for an additional fee. The internet router in this case is considered to be scalable, as its throughput can be dynamically changed as needs grow. A server is considered to be the backend processor in a client-server system. Some server types include database, application, web, file, and backup. For example, a web server is designed to process the HTML requests of a client and display the results in a web browser. Database servers function in a very similar way. As SQL requests are sent by the client, a database server processes the request and the results are sent back to the client as query results. The client is considered to be the front-end processor of a client-server system. This front-end processor sends code to servers to be processed. Some types of clients include desktop and laptop computers, smart home devices, smartphones and tablets, and gaming systems. A great example of a front-end processor is an Amazon Echo. An echo is designed to accept vocal commands from an end user and send these commands to cloud servers for processing. The echo will relay back the results from the server to the end user. Internet file sharing is becoming a more common method for groups of users to collaborate on documents. One of the great benefits of internet file sharing is that documents are stored on cloud servers. These servers have integrated backup systems and file revision management. Users can easily restore back in time a previous version of a file if necessary. Users can also view changes made by other users in a group. Some examples of internet file sharing include Google Drive, Microsoft OneDrive, and Dropbox. Client-side scripting is made up of code that is processed in an internet browser. Client-side scripting brings new functionality to what is displayed in a browser. Things like user authentication, CSS manipulation, form validation, animation effects, social tagging, photo galleries, and file uploaders are all great examples of client-side scripting. JavaScript and jQuery are the two most common client-side scripting languages available today. Server-side extensions are made of code that is processed on a server. Server-side extension code languages like PHP, Ruby on Rails, .NET, and Python offer web developers an expansive set of tools for web application development. Many of these extensions are high-performance, open source, flexible, cost-effective, and cross-platform, which helps to streamline the application development process. Several popular websites like Wikipedia, Facebook, YouTube, Twitter, Hulu, and Google's search engine are built upon these server-side languages. Server-side extensions help to make up the foundation of all things on the internet today.